In today's video, we will be discussing Physics 251, Week 5, Video Explainer problem number 57. In this problem, we are trying to understand how a rubber ball bounces and the motion and forces that are associated with that. So I think that it would be wise for anyone who's having any difficulty with this problem to look back at our Week 5 lecture notes, specifically pages 4 through 21. I think they do a good job at depicting a lot of the concepts that are in this problem. All right, let's get into it. So for part A, we are asked to draw a motion diagram depicting the compression and the expansion of the ball as it touches the floor. All right, so for part A, I have drawn, in addition to our directional acceleration, I have also drawn our velocity. So in the first part, when the ball first hits the ground, and this is with respect to increasing time right here in the x direction, positive x direction, we have a negative velocity pushing the ball towards the ground. So this is also the ball's direction in the negative y direction, and we also have a positive acceleration in this part. So the ball is going down to the ground, it's hitting the ground, and as it's compressing, we have a positive acceleration. This is because the velocity is decreasing across this motion. So this is our equilibrium point right here where our velocity equals 0. So when our velocity equals 0 is kind of our turnaround point, if you will, where the ball starts to expand and go upwards. So since our velocity is decreasing as it gets to this turnaround point, that means that we must have a force acting on the velocity to slow it down, which is indeed our positive acceleration vector right here. So here we have the ball compressing. It's getting wider and wider until it reaches this point where velocity equals 0 and there is positive acceleration. And then from here on out, there is a positive velocity as well as a positive acceleration vector, both in the y direction. All right, so for part B, we have to draw a picture. Draw a picture of the ball and the forces associated with it as it is in contact with the floor. So here we have our force of gravity, of course, as always for any object on Earth. And we also have our normal force because it is on the ground. So in this situation, our normal force is actually going to be greater than our force of gravity because there needs to be something pulling the ball upward as it's moving up. So here, as we notice in part C, we have our net force in the positive y direction because the sum of our forces here is going to be positive. All right, in part D, I have written up a little paragraph here to kind of describe what is happening in this motion, but I will also do a little brief description for you right now. So pretty much what we notice is that the velocity is decreasing until it reaches the turnaround point, at which point it is increasing in velocity positively. So it switches from negative velocity to positive velocity. And all the while, we have a positive acceleration on the ball. So I think that one thing that is important to note is that our ball's net force is always pointing upward, which kind of gives it which allows it to return back upwards to where it started, or near where it started, rather, if we include drag forces and the force of gravity. But yeah, that's pretty much it. I hope you guys found this video helpful, and thank you for watching.